In the previous video about reference angles with degrees, we looked at these rules, which had the assumption that theta was between 0 and 360 degrees. But what happens if theta is not? So here is two examples that will deal with that situation. And unfortunately, the only way we can really do this is use our brain a little bit. So negative 120 degrees, a negative angle will move clockwise. Okay, so positive angles like 460, we would go in this direction first, but a negative angle, we will go down. Negative down, positive up. Pretty simple. So negative 120 degrees would put us into quadrant 3. All right, we know this would be negative 90 and then another 30. So this is negative 120 degrees. A reference angle, however, we've talked about, is the terminal side and the x-axis. So in this case, the negative x-axis. So our reference angle, theta prime, would be right here. All right. So again, we can't use our standard rules for this because theta is not between 0 and 360. But we can just kind of use some common sense here. So our reference angle, this angle measure between the terminal side and the x-axis, would be 60 degrees. And the reason for that is I know that this is, in this case, negative 180. All right, but with our reference angle here, we just want to know this amount of opening. So if this was 180 degrees and 120 is getting taken up, there would be 60 left over. So in this case, theta prime would be equal to 60 degrees. Okay. For 460 degrees, we know that one full revolution is 360. So another 100 would put me into quadrant 2. So that would be what 460 degrees looks like. One full revolution and then another little bit there. Okay. So to figure out the reference angle, again, we just want the angle between the x-axis and the terminal side. Okay. So what would that be? Well, again, there's no formula that we can utilize. We just kind of have to use our brain here. Well, if 360 is getting taken up here, I know that from just this point after that first revolution to here is another 100 degrees. Okay, so this from here to here is 100. So what would be left over to get to here? That would be another 80, because that would, from here going all the way, would be 180 degrees, half a revolution. So our reference angle in this case, theta prime, would be equal to 80 degrees. Okay, so those are a little bit more abstract and just kind of require you to think a little bit. Now, what if we had to find reference angles in radians? Well, if we go back to these rules that we looked at before, we can just plug in the equivalent item in regards to radians. So for example, like for 180 degrees, the equivalent to that in radians is pi. So you'll notice the rule here in quadrant 2, the reference angle will be equal to pi minus theta. Okay, here, same deal. In this one, the conversion factor 360 degrees is equivalent to 2 pi. All right, and that's back from what we learned in the first part of the first video. Anyway, we can utilize those if we had to find a reference angle in radians. So 2 pi over 3, the reference angle for that, we need to figure out where 2 pi over 3 is located. It is in quadrant 2. Now, how do I know it's in quadrant 2? Well, 2/3 is approximately 0.6 repeating, or it is 0.6 repeating, which is smaller than 1 pi, but larger than pi over 2, which is 0.5 pi, right? So this is pi over 2 here, that's pi. 2/3 is between 1/2 and 1. Okay, so this angle right here is 2 pi over 3. We once again want to find this. Okay, so since we're in quadrant 2, we can utilize this rule, which is just pi minus theta. So theta prime will equal pi minus theta. all right, and theta is 2 pi over 3. We need to get a common denominator. So pi with the denominator of 3 would be 3 pi over 3. Okay, notice again that reduces to pi. Subtract 2 pi over 3, that will give us pi over 3. So that's the measure of this angle right there. Okay? Now, negative 5 pi over 6, again, this angle is not between, in this case, 0 and 2 pi. So we can't utilize these rules. So these rules work good if the angle's between 0 and 2 pi, but just like the ones that we had above here, if they're not, we have to kind of use some common sense. So negative 5 pi over 6, it's a negative angle, so we're going to go in the clockwise direction first. That's going to put us in quadrant 3. All right, so from the initial side here, this is the negative 5 pi over 6. How do I know I'm going to be in quadrant 3? Well, same deal. If this is 0 here, I know that a half of a revolution is pi, in this case negative pi, which is negative 1 pi, right? Well, 5/6 is smaller than 1. So it's 5/6 is larger than a half, just kind of like we had here. So it's less than negative a half, or more than negative a half, but smaller than that. So that puts us in quadrant 3. So our reference angle that we're going to be looking for is this, okay? And the way that I would view this is just ask myself, if I'm here, if I get there in 5 pi over 6, how many more pi over 6s would I need to get to 1 pi? Well, in that case, I would need another pi over 6. Right, because 5 pi over 6 plus pi over 6 would give me 6 pi over 6, which is the 1 pi that I would need. So this would be theta prime, in that case, pi over 6. So again, that's a little bit more abstract. What you should notice here with those examples is the reference angle that we're going to be looking for is always positive. So you can sort of ignore the negatives that I had there, because we're just going to want to find the reference angle in terms of a positive value. So you can keep that in mind. Okay. Last component that we're going to address for today is the concept of coterminal angles. We've actually already dealt with these a little bit before, but let's just hypothetically say that we have a 60-degree angle. Well, this is considered to be the terminal side, as we know. However, let's just say I got to 60 degrees, but then for whatever reason I wanted to go around again. Well, you can do that. If I went around again, we know that one full revolution from here is another 360. So if we do 360, that additional revolution, plus what we started with, 60, that gives us 420 degrees. Okay? We could go around again if we wanted, okay? So another 360. That would put us at 780 degrees, okay? So these angles, 780, 420, and 60, all end on the same side, okay? So what do we call those? We call those coterminal angles, all right? This is similar to just a concept like if you stood up and you were facing one direction and you spun around 360 degrees, you'd end up facing the same direction, okay? So it's just that sort of concept. We can have an infinite amount of rotation. You can keep spinning around and around again and again and again. All right, you can keep rotating an angle again and again and again. All right, so we can add 360. We could also subtract 360. So if I wanted to get to this side right here, but go in the negative direction, we could certainly do that. And the way that we could represent that angle would be negative 300 degrees, because we could do 60 degrees minus 360 degrees, which would be negative 300. And if we wanted to rotate around yet again, okay, we could subtract 360 again, that would be negative 660 degrees. Okay, so all those angle measures, again, they have the same terminal side. So we call those coterminal angles. All right. So coterminal angles are angles with the same terminal side. All right, different amount of rotation, but they end up in the same place. In general, what our goal will be is to get the angle between 0 and 360. That's going to be our target once we start incorporating this with finding sine, cosine, tangent, and their reciprocals. Because we're going to have these trig ratios memorized. So we want to get the angle between 0 and 360 if it's in degrees, or between 0 and 2 pi if it is in radians. Degrees is definitely easier. You can see here I have this measure of 570. 570 is obviously bigger than 360. So what we can do to get the angle between 0 and 360 in this case is just subtract 360 degrees. So if we do 570 minus 360, that gives us 210 degrees. That's between 0 and 360. Life is good. Okay? Now, negative 760, a little bit more complicated. That's smaller than 0. So in this case, we could add 360. So if we do negative 760 plus 360, that's going to put us at negative 400 degrees. Well, that's still smaller than 0. So what I'm going to do is add 360 again. Obviously, that will still be smaller than 360. That'll give us negative 40 degrees. Okay? Well, I'll add 360 degrees again. And then that will finally put me between 0 and 360. So 320 degrees. All right, so again, 320, negative 40, negative 400, and negative 760 all have a terminal side that is in common. They're all in common with their terminal side. However, the amount of rotation it takes to get to those is different. Okay, so that is coterminal angles in degrees. In radians, the equivalence of 360 degrees in radians is 2 pi. So if I have 13 pi over 6, 13 divided by 6 is slightly larger than 2. So if my target is to get between 0 and 2 pi, in this case, what we will do is subtract 2 pi, okay? So subtracting 2 pi, same thing as subtracting 360. All right, they're equivalent, but we're in radians. We want to stay in radians. In order to do this, though, we need to get a common denominator. So our denominator here is going to be 6. All right, so we're going to have 13 pi over 6 minus something over 6. Well, what divided by 6 would give me 2 pi? 12 pi would, right? 12 over 6 is 2. Okay, so 13 pi over 6 minus 12 pi over 6 now gives me pi over 6. Pi over 6 is between 0 and 2 pi. That's 1/6 pi, so we're good there. All right. Now, same thing here with 15 pi over 4. However, it is negative. So in this case, instead of, if our target's to get between 0 and 2 pi, we're going to add 2 pi in that case to get that to become positive. So we're going to have to do this quite a bit. All right, so negative 15 pi over 4 plus 2 pi. We need a common denominator of 4. So what divided by 4 gives me 2 pi? It would be 8 pi, right? 8 divided by 4 is 2. So now this gives me negative 7 pi over 4. But that doesn't quite do it because this is still negative. So what do? Just like what I did up here. Here I added 360 again. Here I'm going to add 2 pi again. But I'm going to keep my representation of 2 pi as 8 pi over 4 because it's a common denominator deal, right? So negative 7 pi plus 8 pi gives us pi, and then we put that over 4. So there's our coterminal angle between 0 and 2 pi. Now, some questions will ask you to find a positive and negative coterminal angle with the angle that's given. All right, basically you're just going to add and subtract 360 to make that happen. So like with this one, a positive coterminal angle, what we would need to do is add 360. All right, so negative 500 plus 360 gives us negative 140. Well, negative 140, we could use that as the negative coterminal angle with the given angle. So our given angle, negative 500, this is a negative coterminal. To get to a positive coterminal coterminal angle, which is what this is asking for, along with the negative, is all we need to do is just add 360 again. So you just add 360 again, and you get 220 degrees. So that would be a positive coterminal angle. Okay, so again, all these end or terminate on the same side, but the amount of rotation it takes to get to those is different. All right. If you started here to get the negative coterminal and just subtracted 360 from negative 500 to get negative 860, that would work as well. All right, so you have an infinite amount of answers that you could really utilize here. All right, the same concept would exist if you were dealing with angles in radians. So let's just pick something simple like pi over 3. Okay, if you wanted to get a positive coterminal angle, you could add 2 pi. Well, again, we don't have a common denominator there, so we'll need to get one. That'll be 3. What divided by 3 is 2? 6 divided by 3 is 2. So here is your positive coterminal angle. Your negative coterminal angle, you would take what angle you started with in this case and just subtract 2 pi. So that will give us negative 5 pi over 3. So here is your positive coterminal angle. There is your negative coterminal angle.